Hello students, how are you? I hope all of you are good. Today in this video I am going to start a new chapter, application of integrals. From the point of board exam, the weightage of this chapter is 5 mark. It means you are going to get one question for the 5 mark in your board exam. Here the chapter is application of integrals. The name of the chapter itself visualize that application. Application means what? Uses. Uses of what? Integrals, or in other words integration. So it means in this chapter we are going to learn uses of integration. So integration can be used in many cases, but the main use of integration is to find the area under the curve. Integration is used. Integration is used to find area under the curve. Area under the curve. See here how this integration helps us to find the area under the curve by considering one example. Let's see x-axis, y-axis and origin. And here we have to find area under the curve y equal to fx from x equals to a to x equals to b. Here we have to find area under the curve y equal to fx above the x-axis from the line x equals to a to x equals to b. Just observe this required area. So here the required area is a, b, c, d. So observe this area ABCD. It doesn't look like a circle or it doesn't look like a rectangle. It means we don't have any particular formula to find the area ABCD. So to find the area ABCD, here one is a technique. So the technique is firstly I'm going to consider one of the vertical rectangular strip. One of the vertical rectangular strip of width dx, and definitely its length should be equal to y. From origin to this length is equal to what? Y. Since observe here, considered strip is in rectangle shape. In which shape? Rectangle shape. So this one is what? Rectangular strip. Rectangular strip. So we know the formula to find the area of the rectangle in geometry. So the area of the rectangle in geometry is what? Length into breadth. So here we considered a strip. We considered a strip whose width is dx, length is y. Therefore, area of this particular rectangular strip is y into dx. So length into breadth. Length is y, breadth is dx. Therefore, area of this particular strip is what? Y into dx. So we obtained only the area of this considered strip, but we need area ABCD. So to find the area ABCD, firstly I am going to divide this entire area by the small vertical strips. By small vertical strips, and then I am going to find the area of each strips. I am going to find the area of each strips. Area of the first strip, second strip, third strip, fourth strip and fifth strip. And then I am going to add the area of each strips. That addition quantity is equal to area of this ABC. It means the sum of area of this strips is equal to what? Required area ABCD. So that summation obtained by integrating this y into dx. That summation is obtained by what? Integrating this area y into dx from what? A to B, because we considered strips in the area ABCD. It means from x equals to A to x equals to B. So therefore required area ABCD should be equal to integration from A to B y dx, or in other words integration from A to B. What is y? y is fx. So fx dx. I hope all of you understood. So this area obtained above the x-axis means on x-axis. So the obtained area is what? Area on x-axis. On what? X-axis. Suppose the question to find the area on y-axis. See here, let us consider one more example. Let us consider one more example. Let x-axis, y-axis, origin, and suppose we have to find the area of the curve x equals to g of y, x equals to g of y from the line y equal to a to y equal to b. It means here the required area is P, Q, R, S. So again to find this area PQRS, I am going to consider one of the strip here, but that strip is horizontal rectangular strip. So let us consider one of the horizontal rectangular strip of width along the y-axis consider ಮಾಡ್ತಾ ಇದೀವಿ. So consider a horizontal rectangular strip of width dy and length should be equal to nodri from this to origin. This length should be equal to what? X. I hope all of you understanding. So considered one rectangular strip whose width is dy, length is x. Therefore, area of this considered strip is what? Length into breadth. It is nothing but x into dy. X into dy. But we need this entire area PQRS. So obtained by what? Integrating from y equal to a to y equal to b. From a to b. Or in other words, integration from a to b. What is x? X is g of y. So g of y dy. I hope all of you understanding. And if suppose here, observe here, we considered area in the first quadrant. In this first quadrant, y is positive. In the second quadrant, in the second example, we considered area in the first quadrant. Here also x is positive. If suppose, consider one more example here. Third example is, let's say x-axis, y-axis, origin, and this one is a fourth quadrant. First quadrant, second quadrant, third quadrant, fourth quadrant, and the curve is in the fourth quadrant, and we have to find the area bounded by the curve y equal to fx, from the line x equals to a to x equals to b. Here the required area in fourth quadrant, and to find this required area A, B, C, D, again same technique. I am going to consider one of the vertical rectangular strip. Let us consider one of the vertical rectangular strip of width dx, length y inside the required area ABCD. It means required area of this vertical strip is length into breadth. It means y into dx. But observe here, y is negative in fourth quadrant, but area is always a positive quantity. So to find the entire area ABCD, as you know that we need to integrate from A to B. So this is a required area ABCD, but the obtained area in a negative sign, but area is always positive quantity. That's why we need to use a modulus here. Here modulus, or it can also be equal to modulus of integration from a to b. What is y? Fx dx. I hope all of you understood the concept of application of integrals, how to find the area bounded by the curve. And one more thing, this chapter application of integrals is related to one of the chapter which is studied in your first PUC. That is what? Conic section. This chapter is related to what? Chapter conic section which is studied in your first PUC. So in this chapter, you learned circles, and then parabolas, and then parabolas, and then ellipses, and then ellipses, and then hyperbolas. But for this chapter, circle, parabola, and ellipse is enough. So in these concepts, to solve the problems from the chapter application of integrals, we just know equation of circles and their graphs, equation of parabolas and their graphs, equation of ellipse and their graphs. Then only we are able to solve the problems based on this application of integral chapter. So without wasting the time, let's start the recalling of the equation of circle, parabolas, ellipse, and their graphs. First one is a circle with the center HK and radius R. Let's say this is the x-axis, y-axis, origin. See here, equation of the circle with the center HK and radius R is given by x minus h whole square plus y minus k whole square equal to r square, where hk is the center of the circle, r is radius of the circle, and xy be any point on the circle. I hope all of you understanding. And the second one is a circle with center origin, with center origin and radius r, and this is a y-axis, x-axis. See here, second circle is a circle whose center is origin, radius is r. Therefore, its equation is obtained by substituting the coordinates of center in the first equation of circle. It means the equation of second circle is, it means the equation of the second circle is x minus 0 whole square. These are the values of h and k, center of the circles. X minus 0 is x, so x square, plus y minus 0 is y square, equal to r square. I hope all of you understanding. So one more thing you need to observe here. A is a point of intersection of x-axis and this circle. It means coordinates of this point A is a point on x-axis, therefore its y coordinate is 0. And this OA length is radius of the circle, its length is equals to r, therefore coordinates of point A is r comma 0. I hope all of you understood. So this much of data is enough for the circle to solve the problems on the basis of application of integrals. Let's see, the second one is ellipse. We studied two types of ellipses in the first PUC. First one is a horizontal ellipse and second one is a vertical ellipse. So equation of the horizontal ellipse is, equation of this horizontal ellipse is x square divided by a square plus y square divided by b square equals to 1. And equation of vertical ellipse is x square divides b square plus y square divided by a square equals to 1. And one more thing, in both the ellipses, the value of a is greater than b. If a is with x, it is a horizontal ellipse. If a is with y, it is a vertical ellipse. I hope all of you understanding. And the center of both the ellipses is origin. So this one is a x-axis and y-axis. Here also same thing, x-axis and y-axis. Now see here, for the horizontal ellipse, the major axis is x-axis. What is this x-axis? X-axis is a major axis of the horizontal ellipse. And end points of this major axis are called as vertices of the ellipse. Vertices of the ellipse. It means A and A dash are the vertices of the ellipse. And the coordinates of the point A and A dash, since A and A dash both lies on the x-axis, therefore for both points y coordinate is 0. For both the points y coordinate is 0. And x coordinate of the point A obtained by substituting 0, it means value of y in the equation of ellipse. If you substitute the value of y 0 in this equation, so 0 by b square, it means second quantity will becomes 0. Remains what? X square by a square. Remains x square by a square equals to 1. By cross multiplying, we get x square is equals to a square. It means square get cancelled. X is equals to what? A. x is equals to a. Therefore, x coordinate of the point A on positive x-axis plus a, on a negative x-axis minus a. I hope all of you understood. And this much of data is enough for the horizontal ellipse, and similarly for the vertical ellipse. Again, here the major axis is y-axis because A is with y, and end points of this major axis are called as vertices of the ellipse. And one more thing you need to observe here, end points of the ellipse on y-axis also obtained by, for example, let's say this is a B point and B dash point. So B and B dash on y-axis, therefore their x coordinates are 0, and y coordinate obtained by substituting this value of x in the equation of ellipse. It means if we substitute x equals to 0, so 0 by a square is 0, y square by b square equals to 1. It means y square equals to b square. ಏನು ಬರುತ್ತೆ? y square by b square. ಇದು ಪೂರಾ 0 ಆಗುತ್ತೆ, x 0 substitute ಮಾಡೋದ್ರಿಂದ. y square by b square equals to 1. It means y square is equals to b square by the cross multiplying. Square get cancelled, so y equal to b means y coordinate of point b is b, and y coordinate of the point B, since this is on negative y-axis, therefore minus b. I hope all of you understanding. And here the vertical ellipse, here the major axis is y-axis. Suppose A and A dash are the vertices of the ellipse, and the coordinates of point A and A dash are. See here, ನೋಡ್ರಿ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, since the points A and A dash on y-axis, therefore its x coordinates are 0. If x is 0, y square by b square equals to 1. It means y square is equals to a square. Square get cancelled, the value of y is a. Here also the value of y is minus a. Similarly, the end points of this ellipse on the x-axis, suppose b and b dash, and the coordinates of point B, since it is on x-axis, y coordinate is 0. For the point B dash also, y coordinate is 0. And the x coordinate of this point B and B dash obtained by substituting this value of y in the equation of ellipse. So value of y is 0, 0 by a square is 0. So we got what? X square by b square equals to 1. By cross multiplying, x square equals to b square. Square get cancelled, x is equals to b. On positive x-axis, coordinates of point B is b comma 0, and negative x-axis minus b comma 0. And this much of data is enough to solve the problems on application of integrals. And one more thing you need to observe here, ellipse, circles are the symmetrical figures. Symmetrical figures means equal area is distributed in the first quadrant, second quadrant, third and fourth quadrant. I hope all of you understanding. Area bounded by the circle above the x-axis equal to area bounded by the circle below the x-axis. And similarly, area bounded by this circle to the right side of the y-axis is equal to area bounded by this circle to the left side of the y-axis. And similarly, in ellipse also same thing. Area in the first quadrant A1, area in the second quadrant A2, area in the third quadrant A3, area in the fourth quadrant A4. Ellipse is also symmetrical figure. Therefore, A1 is equals to A2 is equals to A3 is equals to A4. Similarly for the vertical ellipse also. I hope all of you understanding. Let's see the concept of parabolas, because we need the equation of parabolas also to solve the problems on application of integrals. We studied totally 4 different parabolas in the chapter conic section. First one is a right parabola, and the equation of right parabola is y square is equals to 4ax, y square equals to 4ax. So this is a vertex of the parabola, origin, x-axis, y-axis, and f is a focus of the parabola whose coordinates are a comma 0. I hope all of you understand. And second one is a left parabola. Second one is a left parabola, and whose equation is y square is equals to minus 4ax. Here also origin is vertex of the parabola. Coordinates of focus is minus a comma 0. This one is a x-axis and this is a y-axis. Third one is a upward parabola, and its equation is x square is equals to 4ay where origin is a vertex of the parabola and coordinates of the focus is 0 comma a. This one is a x-axis and y-axis. I hope all of you understanding. And the fourth one is a downward parabola, and its equation is x square is equals to minus 4ay, x square is equals to minus 4ay, where origin is vertex of the parabola, this is a x-axis and y-axis. And one more thing, the coordinates of the focus for the downward parabola is 0 comma minus e. I hope all of you understood. And one more thing, parabolas is also symmetrical figures. It means area bounded by the parabola above the x-axis is equals to area bounded by the parabola below the x-axis, as well as area bounded by the parabola to the right side of the y-axis is equal to area bounded by the parabola with the left side of the y-axis. For example, so in the first quadrant, area bounded by the parabola is A1. In second quadrant, A2. From the definition of symmetrical figures, A1 is equals to A2. And for this upward parabola also, suppose area bounded by this parabola to the right side of the y-axis is A1 and left side of the y-axis A2. Then by the definition of symmetrical figures, A1 is equals to A2. I hope all of you understood. This much of data is enough for the parabolas to calculate or to solve the problems on application of integrals. Without wasting the time, let's start the questions. And the first question is, here the first question is, find the area enclosed by the circle x square plus y square equals to a square. The most important question for your board exam. So here the equation of circle is x square plus y square is equals to a square. Means center of the circle is origin and radius of the circle is a. And one more thing you need to observe here, we know that already area of the circle in a geometry, area of the circle is equals to pi into r square, where r is a, therefore area of this circle definitely equal to what? Pi a square. But we need to calculate using integration, then only you are going to get the marks in your board exam. ನಾವು ಎದರ್ಲಿಂದ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? ಬೈ ಯೂಸಿಂಗ್ ಇಂಟಿಗ್ರೇಷನ್. ಸೊ ಇಂಟಿಗ್ರೇಷನ್ ಲಿಂದ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದಾಗ ಆನ್ಸರ್ ಏನು ಬರುತ್ತೆ ನೋಡ್ರಿ, ಪೈ ಎ ಸ್ಕ್ವೇರ್. ಸೇರ್ ಹೌ we calculate this area of the circle using the integration. So when we are solving or when we are finding area of the curves, so first step is we need to draw the rough figures. See here, first thing I am going to draw this circle, y-axis, x-axis and origin. Given is a circle with center, origin, radius is a. It means this is the given circle whose center is origin and radius is equals to a. It means length of OA is equals to a. I hope all of you understanding. And since a is on x-axis, therefore coordinates of the point a is y coordinate should be equal to 0 and length of OA is equals to x coordinate. Length of OA is a units because radius of the circle. And one more thing, we know that already circle is a symmetrical figure. It means area bounded by this circle in the first quadrant is equal to area bounded by this circle in the second quadrant, which is equals to third quadrant, and as well as it is equal to fourth quadrant. Let's say area in the first quadrant is equals to A1 and area in the second quadrant equals to A2 and area in the third quadrant is A3 and in fourth quadrant is A4. From the definition of symmetrical figure, definitely area 1 equals to area 2 equals to area 3 equals to area 4. It means to identify the area bounded by this circle, no need to calculate the entire area. Just find the area in the first quadrant. Suppose area in the first quadrant is A1. Then entire area bounded by this circle should be equal to what? 4 times of A1. So required area is equal to, let's say A. So 4 times of area of OAB anta barkobodu. 4 times of area in the first quadrant OAB. Area in the first quadrant OAB. It is nothing but entire area bounded by this circle. I hope all of you understanding. Here I am just calculating the area in which quadrant? First quadrant. Let's set the area in the first quadrant. And here I am going to consider one of the vertical strip. One of the vertical strip of width dx. Definitely length is equals to y. Therefore, area of this particular strip is y into dx. Area of this particular strip is y into dx. But we need the entire area in the first quadrant. That's why I'm going to integrate from ಎಲ್ಲಿಂದ ನೋಡ್ರಿ 0 to a. From 0 to a. Therefore, required area is equals to 4 times of integration from 0 to a y into dx. I hope all of you understanding. Now we need this y. Y is obtained by what? Given equation of circle. Here the equation is x square plus y square is equals to a square. It means y square is equals to a square minus x square. It means y is equals to plus minus square root of a square. Y is equals to plus minus square root of a square minus x square. But I consider only positive value of y. Positive value of y. Because we are finding area in the first quadrant. In first quadrant, y is always positive. I hope all of you understanding. Now substitute this value of y in this equation. So therefore, area is equals to 4 times of integration from 0 to a y square root of a square minus x square dx. I hope all of you understanding. Idu tagiti nodri. Now see here. Integration from square root of a square minus x square. We have one of the standard formula in particular functions. That is what? Integration of square root of a square minus x square is equals to x by 2 square root of a square minus x square plus a square by 2 into sine inverse of x by a plus c. Therefore, area is equals to 4 times of integration of root a square minus x square is x by 2 square root of a square minus x square plus a square by 2 into sine inverse of x by a. Since this is a definite integral, no need to write plus c. Over the limits 0 to a. I hope all of you understanding. What next? Apply the limits. Area is equals to 4 times of upper limit x by 2 into square root of a square minus x square means a square plus a square by 2 into sine inverse of a by a. So now upper limit is completed. What next? Minus lower limit is 0. So 0 by 2 into square root of a square minus 0 square plus a square by 2 into sine inverse of 0 by a. I hope all of you understanding. Now see here, area is equals to 4 times of, observe here, a square minus a square is 0. So 0 into anything 0. So first term is 0 plus a square by 2 into here a and a get cancelled, sine inverse 1. And we know that the value of sine inverse 1 is pi by 2. I hope all of you understanding. Now minus into plus minus. Again 0 by 2 is 0. 0 into anything 0. So it means first quantity is 0. Next minus into plus minus a square by 2 into sine inverse of 0 by a. 0 by a is equals to 0 and the value of sine inverse 0 is 0. I hope all of you understanding. Finally, a square by 2 into 0. This entire second value is equals to what? 0. So therefore, area is equals to 4 times of pi into a square divided by 2 into 2, 4. Here I can cancel 4 and 4. So therefore, finally we got area is equals to pi into a square units. I hope all of you understood. First ಹೇಳಿದ್ದೆ ನಾನು geometry ಒಳಗೆ area of the circle ಏನು ಬರ್ತದೆ pi a square. In the same way also we are going to calculate the area of circle using integration, and also we got the area is equals to pi a square units. I hope all of you understood.